This is Business Administration 2843, Business Statistics. I'm Chris Rule, the instructor. Today we're looking at binomial probability and Poisson, which is the French word for fish. First we'll look at binomial probability. I put the formula, as it's given in your book, on the spreadsheet so we can reference it. And we want to find the probability, which is the possibility of achieving some result. And to do that, we need to understand the formula first. C denotes combination. It's here. N is the number of trials. X is the random variable, which really you should think of as the number of successes. And pi is the probability of success on each trial. So I used the results here. I used a problem from the Smart Book assignment. A bowl contains 2 red and 3 black marbles. Marbles randomly selected, its color noted, and returned to the bowl. Now that's important because the probability won't change for each draw because we return the marble to the bowl, so we still have 5 marbles each time. Success is getting a red marble. Use the formula over here to find the chance of getting 3 red marbles in 8 draws. So N is the number of trials. We have 8 draws, so that's 8 trials. We want to get 3 reds, so that's the number of successes we're looking for. The probability, pi, comes from this down here. In this problem, each marble is 20% because you have 5 marbles that are equal. They total 100%. 100 divided by 5 is 20. Since 2 of them are red, 20 plus 20, there's a 40% chance the result will be a red marble. 40% is the same as 0.4, so the probability of success on each trial, pi, is 0.4. That's where that came from. So you put these in. Now we have to do 3 different calculations over here. Let's start with this middle one, pi to the x. Pi to the x power, right here. Well, pi is 0.4, and x is 3. So 0.4 cubed, 0.4 times 0.4 times 0.4 is 0.064. All right, so that's that middle part. Now, on the right here, we have 1 minus pi, which is given right here. Pi is 0.4, so 1 minus pi is 0.6. Because if you add up 0.4 and 0.6, you get 1. So that's this middle part. Now we take that answer, that 0.6, to the power of n minus 5. Right down here is n minus 5, or x, sorry, n minus x. N is 8, x is 3, take the difference, it's 5. So we're going to take 0.6 to the 5th power, and we get 0.078. So this is part of the answer, and this is part of the answer. The other part of the answer is C, and C is a bit complicated. You have to do a couple of calculations. Here's how you do it. You take the factorial, and when we're writing this on paper, we use the number followed by an exclamation point. The factorial of n, so that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, divided by the product of these two. The factorial of x, so 3 exclamation point, times the factorial of, this should be n minus x, this one right here. So the factorial of x times the factorial of n minus x. We get that product, and then we take the factorial of n divided by that product, and it comes out to be 56. So to get p, the probability of x, probability of getting 3 red marbles, we take c times 0.078 times 0.064. And it comes out to, and I'm going to expand these one. And I think your book just does 3 spots. Comes out to 0.279, which is this one right here, second option. And the probability, I put this in because the probability of not getting 3 red marbles is 72%, 72.1%. So it's much more likely that you won't get 3 red marbles in 8 draws. It's about a 28% chance that you will. So you're very lucky if you get that. So the way this is set up, over here are the instructions. Enter n, x, and pi in the tan boxes, and the probability px, and also 1 minus px will show up over here. So you should be able to use this for any of your problems related to binomial probability. And I'm going to be sending this out. Now, let's look at the fish probability. This is if you have a set number. You have 8 draws, for example. What if you have different numbers? So there's a example. Oh, before I go on page 170, there's an error, printing error. It gives you the mean of a binomial distribution as mu equals n times pi. It's formula 6-4 on page 170. Below that it says the mean of a binomial distribution. And it gives you another formula, 6-5. They copied and pasted. That should be the variance of a binomial distribution. So mark that out on your textbook. The second instance, the one that's associated with 6-5, should say variance, not mean. That's an error in the book. So take note of that. All right, now to go to the Poisson probability distribution, also known as the fish, we have a formula. And it's right here. The number of times that some event occurs during a defined interval, the probability of an event proportional to the size of the interval, and the intervals do not overlap and are independent. So we have the formula right here. We have mu to the x times natural log e to the minus mu over x factorial. And down here we have some information. Mu is the mean number of occurrences, number of successes in a particular interval. E is a constant. That's why I just put it in here as a constant. It's built into Excel. X is the number of successes, again, and Px is the probability for a specified value of x. Also, the mean of the distribution can be defined as mu equals n pi. So I put a spot up here for n and for pi, and then did a formula for n times pi, which would be equal to mu if they don't give it to you. So you may need to put in n, x, mu, and pi to get the answer. Let's look first at the example problem that they gave on page 178, 179. They said they had an airline, Budget Airlines, and they were checking the number of bags that were lost per flight. There were 20 bags lost on 500 flights. So what is the mean number of bags lost per flight? What's the likelihood that no bags were lost? What's the probability that at least one bag was lost? All right, first of all, we need to figure out mu, or the mean number of bags lost per flight. We had 20 bags lost over 500 during 500 flights. If you take 20 divided by 500, you get 0.04. That's the average number of bags lost per flight. So I can put 0.04 in for mu. Now, if they didn't lose a bag, X would be 0. And your book shows 0.9608 probability. Number of bags lost, there's a 96.1% chance that you're not going to lose a bag. Most of the time you won't lose a bag. All right? What if you lost one bag? The average is still 0.04. I'll just put, okay, let's say if you lost one bag. What's the probability of losing one bag? 3.84%, which is what they got. By the way, there's another error in your book. This formula is found on page 179. And in the formula of the probability of exactly one lost bag is, when it shows 0.04, it shows it to the 0 power. That's supposed to be X, but in the second case, X is 1. So that 0 on there should be a 1. The answer is correct, but the way they printed it there, it's incorrect. And the probability of one or more lost bags, the third thing they mentioned there, I put a 0 in again. Now they're saying probability of one or more lost bags. This is a probability, this 96.1% is the chance of, most of the time there won't be a lost bag. Well, what's the chance of losing a bag? Any bag? 3.92%. And beyond that, if I put a 2 in here, it's 0.0008. If I go to a 3, there's no chance. Losing 3 bags. So it's 0 from then on out. And that goes along with the table that they have. All right, so let's look at another one. Another example, Coastal Insurance Company underwrites property for beachfront properties in Virginia, North and South Carolina, and Georgia. And they're concerned about hurricanes. St. Simons Island in Georgia, the estimates probability of a hurricane in any 1 year is 0.05. So the probability is 0.05, and the mortgage is 30 years. That would be pi, not x. So 30 years times 0.05 gives you a mu of 1.5. That's going to be our average. So I'm going to put that in there. So what's the chance of no storms hitting the island? The chance of no storms hitting the island is 77.69%, about 78%. Or at least, let's see. Yeah, this is the probability of a storm hitting the island. This is the probability of no storm, 0 storms hitting the island. 1 minus that would be the probability of a storm hitting the island. All right, so that's using this method. What if I do this over here? N is 30, pi is 1.5. What is pi? 0.05. 0.05, and x is 0. So we use the binomial probability formula, and we come up with, there's a 78.5% chance of a hurricane hitting the island. Over here, we have a 77.69% chance of a hurricane hitting the island within the 30-year period. So both answers are fairly close. But running through these examples can verify that these formulas work. And you have to be able to use these formulas. Well, here's a couple of spreadsheets. I'll send these out, and I want you to try to work some of the exercises at the end of chapter 6 related to both of these probability formulas, and see that you can understand what's going on here based on what these are called. Now, you may not get exactly the same answer because of how far Excel takes natural log, but you should get very close enough to answer any of the questions that they have.